Okay. So Abir, in the last class we started with friction, but we just did one numerical from friction, right? So let me share a question from this, and that means from this topic of friction only. Because last time we just completed the pulley problems. Okay, Abhi. So see, this is the question from NEET 2020, and these are the options from it. First, write the question, make the figure, and what write all the forces that are acting. See, this is a very short and easy question. So the concept of tension is applied. Basically, you have to tell the acceleration. So take 2 minutes, then I'll discuss it. Yes, right. So option E. So see, how did you solve it? Tell me the steps.
Ma'am, I use the formula G sine theta minus U.
G sine theta minus U cos theta. What is theta here?
Ma'am, we can take the angle of, we can take 90-degree, right?
Why? There is no
For
involvement of angle here.
okay, ma'am.
What are the forces that are acting? All the forces, what you can think.
First gravity and then the normal force.
Gravity will definitely act. Okay, the normal reaction will act here. Gravity will act here. Anything else? Without that, how did you get the answer without the forces? No. Tension. The first, whenever you see string is there, rope is there, thread is there, always get your tension at its first place. Okay.
Yes.
Now, when you're talking about this, if this is a rough surface, on the opposite side, the frictional force will act. Now, see how to solve this question. Jobita, you can write down the question later. Okay, just first pay attention, then copy it. So this is the friction force acting. Now this is moving forward. So this is the direction of acceleration. It is going downwards. This is the direction of acceleration. We always take the direction of acceleration as positive. So if I talk about this part, frictional force is equal to mu n according to the formula. So I'll get tension minus mu n is equal to mass into acceleration, ma. mt means mass of the trolley. So this will be T minus mu n is equal to 10A. This is from this because this side is positive. Wherever acceleration is directed, that side becomes positive. So acceleration is acting towards the right. So all the forces that are acting towards the right will be positive. Like this tension, this will be positive. Friction force is in the opposite direction as that of acceleration. So this will be negative. That's why I've taken this as minus mu n. Now what is T minus mu n now? T minus mu n is the net force. And we know that force is equal to mass into acceleration. So force I have calculated as T minus mu n. Acceleration into mass is 10A. First tell me, is this line clear?
Yes, ma'am.
Okay. Now regarding mu is given in the question 0.05. So if I put this value of mu for tension, see tension we don't know, minus 0.05. All right. See normal reaction, the way you only answered Abir that the gravitational force is acting. So if you look here, normal reaction and mg, they are balancing each other. They are exactly equal because there is no net movement along y-axis. It is not moving up and down, right? So if this is exactly in the opposite side, normal reaction will be equal to the gravitational force, mg. So if I take mg, so see, n normal reaction is equal to mg. Mass is 10, g is 10. So that would be 100. So into 100 is equal to 10a. So this equation is T minus 5 is equal to 10a. This is one equation. Okay, this cannot be solved further. Now I have taken this part, trolley part. Now I'll take this block. In this block, which force is acting towards acceleration? Look in the figure. Tell me here in this block part. Which force is acting along acceleration?
Gravity.
mg. Yes, gravitational force. So mg will be positive this time and tension will be negative this time. Okay. So this will be mg minus T is equal to, so this is the net force is equal to ma. Now, what is mg? Mass is 2, g minus t, again mass is 2, a. So 2g means 20. So equation will become 20 minus t is equal to 2a. That becomes the second equation. Now see, you have two equations. First equation is this. Second equation is this. Now, two equations, two variables, that's what you have to solve. Okay, and when you will solve, you'll get the same answer which you were getting. So it will be like not that answer, that is the option is correct, but that is just a guess which worked, but the actual answer will come through this only, because if you apply any other method in such questions, and just in case if it doesn't work, you'll get the answer exactly wrong. So in these cases, work like this. So when you add these two equations, it will be 20 minus 5 is equal to 12a, because tension will be cancelled. So this becomes 15 is equal to 12a. Acceleration will be 15 divided by 12, which is equal to 5 by 4. And 5 by 4 is 1.25 meter per second square. So this is how you will get 1.25 meter per second square. So these two equations are important. Okay, all those who were not there, first write down the question and then start copying the answer. Yeah, so option A is correct, but this is the method. Abir, it's clear to you now?
Yes, ma'am.
Okay, write down everyone.
Ma'am, can you please scroll down?
Done.
Yes, ma'am.
Okay, class, I'm discussing now. This says that a body of mass m is kept on a rough horizontal surface. So coefficient of friction is mu. Horizontal force is applied on the body, but it does not move. The resultant of normal reaction and the frictional force acting on the body. So first you have to make the free body diagram of it. Now you have kept the block. What all forces are acting? Downwards, the gravitational force will act. That is mg. And perpendicular to it, you will have the normal reaction, correct? Now see, this is saying that the body is kept on a horizontal rough surface. Coefficient of friction is also given. So what will happen? The frictional force will be acting. Okay. Now this is saying what is their resultant that has been formed. So see, this is one force, this is second force, this is the figure, this is the figure which you have to keep in mind. Now look, this is simply making angle 90 degree. Now look, Abir, now your 90 degree and your angles will come, because normal reaction and friction force, these are the two forces that are available. So what will happen? Your net force will be equal to under root of frictional force square plus normal reaction whole square. Why are we taking this? Because cos 90 degree is 0, right? Cos 90 degree is 0. So even if you're expanding it, under root a square plus b square plus 2ab cos theta, theta is simply 90 degree, right? So cos 90 0. This is it. Now what will friction be written as? Mu n, right? And N is equal to mg. See, frictional force is mu N and N is equal to mg. So what we can write here is F will be mu N whole square plus N whole square under root. N can be written as mg. So this will be mu mg whole square plus mg. Normal reaction is equal to mg. Now, mg, if I take out, under root 1 plus mu square will be left. Now see, this is the minimum force required to move the object. But the body is not moving, right? Here the body is not moving. So this will not exactly be equal. It will be less than or equal to this mg under root 1 plus mu square. So which option is this? C, right? So this will be C option. Okay, write it. So easy, you just have to make the figure in such questions. Please write down this. Done?
Yes,
Just a minute, ma'am. Done, ma'am.
Okay, class, I'm discussing this. So this says that which one of the following statements is incorrect? So frictional force opposes the relative motion. This is right. It does the work of opposition only, provided a rough surface is there. Limiting value of static friction is directly proportional to normal reaction. Every value of friction is directly proportional to normal reaction. That is the law. So this is also right. It says rolling friction is smaller than sliding friction. Correct. Rolling friction, because in rolling you have both the components of translation and rotation. So it is lesser. Coefficient of sliding friction has dimensions of length. Frictional force is equal to mu n. Mu is equal to force by n. This has the unit normal reaction. Sorry, a Newton. This has the unit Newton because both are the forces cancel. It is dimensionless. So this will be wrong. Okay, this is a dimensionless quantity. Though it is a dimensionless quantity as well as it is a unitless quantity. Okay, no dimensions, no unit option. Write this quickly and just text me done once we are completed with writing part.
Done, ma'am.
Okay then, let's